So inequalities, not hard stuff. You've done this before. There's maybe one little new thing we'll add, but it's pretty minor. We're going to look at maybe just how we graph inequalities, how we represent inequalities using interval notation, which I believe will be new, and then how we solve inequalities, which is no big deal. So when we graph inequalities, remind me how this works here real quick. When we graph inequalities, we would use a closed dot for which kind of inequalities, if we're graphing an inequality on a number line. When do we make the dot closed, as opposed to open? Remember? What do you think? When is it a closed dot? Like, for example, if I was going to graph this inequality right here, x is greater than or equal to 8. Let's just say that that's 8 right there. And that's 7, and that's 9, and so forth. How would I graph that? I'd use closed, wouldn't I? I'd use a closed dot, and then I would shade in which direction? To the right, because I'm taking values of x that are greater than 8, so that are more positive than 8, right? On the number line, if I go to the right forever, I'm going towards positive infinity. And if I go to the left forever, I'm going towards negative infinity. Okay, so then we use a closed dot. There was one example. If I had a greater than or equal to, what's the other one, obviously? Okay, but what's the other instance where I'd use a closed dot for greater than or equal to, or
Less than or equal to.
less than or equal to? Good. And then I'd use an open one for greater than and less than. Good. And so if we took the other example,
Oh, God.
that's not good. There we go. Okay, so if, let me make this a little more legible. There we go. So if we were going to graph this inequality, a is less than negative 1. So let's say that's negative 1. What am I putting? What kind of endpoint? Open or closed? Open. And I'm shading to the left. So I'll draw a ray to the left. Okay, so now what about interval notation? So interval notation is just another way for us to write intervals of numbers. So in this case, it's going to be solutions to inequalities. The only tools I have for interval notation are infinity symbols, parentheses and brackets, and then a comma. Okay. So the way I would write this, like if I wanted to write, for example, I'm going to put up a different one for just a second. Say we had this interval right here. Say we were going to go from -1 up to +7 in our interval. And this is the way I graphed it. Thank you. Oh my gosh, so smooth. So which endpoint is being included, the left or the right, on this interval? Which interval is being included here, the left or the right? The right. So if an ant were, this was his universe. All he could walk on was this number line. This interval. He could walk all the way up to 7 and step on x equals 7, but he could never. There's a hole there. He could never step on x equals -1, could he? He could go up infinitely close to it, but he could never actually step on -1. So the way I would represent that using interval notation, here's how it works. We put a comma in the middle, and the number that represents the left endpoint goes to the left of the comma. The number that represents the right endpoint goes to the right of the comma. And we either use parentheses or brackets to indicate are we including the endpoint or not. We use parentheses if we're not including the endpoint, and we use brackets if we are. Now there's an easy way to remember that. What uses more ink, a closed dot or an open dot? Closed dot. It takes more ink to draw the equal sign with the inequality, right? And it also takes more ink to draw a bracket than parentheses, right? So more ink always goes with more ink, right? So then we'd say our rules for inequality notation are just that parentheses do not include the endpoints, so those are open dots. Brackets include the endpoints, so those are closed dots. So if we go back to this example we did, x is greater than or equal to 8, how are we going to do that one? That's a little bit different. What do you think, though? Down here we had a left and a right endpoint. This one has a left endpoint, but no right endpoint. What do you think we might do? What do you think? Say it again. Same thing. Same. So on the left, I'm going to put an 8. What's going to go on the right? There is none. So what do you think? Well, 0, I can see why, but if I put 0, that would imply that there is an endpoint and it's at x equals 0, and that actually wouldn't work because 0, this number would have to be bigger than 8, wouldn't it, on the number line? It'd have to go in numerical order because they match, they match left and right endpoints on a number line. The right endpoint would always have to be bigger. But how do you think I could say it's going forever? Infinity, there you go, because this ray goes out forever, doesn't it? So that's what I would put. I'd put 8 comma infinity because there is no endpoint. Now, do I put a bracket or a rounded parentheses for the 8? Bracket. Got to put a bracket. Okay, here's the question. What do I put with infinity? Bracket. I can see arguments for both, but there's one that's right and one that's wrong. If I put a bracket, what does a bracket mean again?
I can step on it.
Okay, so I could step on it. It includes the endpoint.
Oh.
Okay, you want to change your answer?
Yeah.
Yeah, you could never include infinity, could you? Right. Infinity is not a number. If an ant were walking along the x-axis or the real number line and he's trying to get to infinity, as soon as he thinks he's there, well, how much further does he really have to go? A lot. In fact, how much more? Infinite more, right? You can never get there. So whenever we involve an infinity using interval notation, it always has to go with a rounded bracket because you can never get there, right? All that means is the interval where, we're greater than, where x is greater than or equal to 8 forever, right? So there is no other endpoint. What about this one? A is less than -1.
We do infinite -1.
Ah, there you go. So now there's no left boundary. So we're going to have all the way from negative infinity up to, but what's my right endpoint? -1. Okay, is -1 going to get rounded or square brackets? Rounded, good. And of course the infinity has to also, doesn't it? Okay, good. All right, we get the idea. So interval notation, no big deal. Solving inequalities, that's really what the rest, I want to go through 4 or 5 little examples to just kind of get you up to speed on solving inequalities. And you've done some of this already, I know you have. The nice thing about this is, solving inequalities, we follow the same rules to solve an inequality as we do to solve an equation, with one exception, at least for now. Probably for all year this year. There's only one exception. If I multiply or divide by a negative number, what do I have to do to the inequality? Remember?
Make it negative.
Like for example, let's take a quick example here. Like if I did something like, say I had -3x plus 1 is greater than 7. What are the steps to isolate x? Because if I'm solving an inequality, I'm just isolating a variable. Subtract 1. Okay, so the first step would be subtract 1. And that's going to cancel the ones. I'm going to get -3x is greater than 6. Now what? Divide by -3. Okay, so if I divide each side by -3, I wrote that in red there. What happens if I divide each side by a negative? Do you remember? Something really important happens. Well, that's going to turn negative, you're right. So the numbers we're going to get, it's going to cancel the -3's. I'm going to get an x on that side. I'm going to get a -2. Yeah, I got to flip it. Yeah, there's the thing, right? Because I've got those negatives, I divided by negatives, I have to flip that inequality sign around, okay? So there's the only exception. If I multiply or divide both sides of an inequality by a negative number, I must flip the inequality, okay? All right, let's look at some examples. So these look an awful lot like the equations you were doing a couple weeks ago, solving the equations, only they're inequalities. Right? I'm just trying to solve for x. I've got to do a little bit of simplifying, don't I? 'Cause I can't point to a single x, but as soon as I can, my goal is just going to be to isolate the x on one side of the inequality. And that's it. Okay, so what are the steps I would go through to solve this? Just treat it like an equation. And right now I've got multiple x's, so I got to make things simpler. How do I make things simpler? Distribute. There we go. Good. So I can distribute the -3, and that's going to give me 21x. Well, I have to distribute the whole -3, so I'm going to get -15x. Help me out. Say it again. -27. I've got to distribute the -3. So on the other side, we've got a 7. Now what? Combine. 21x minus 15x, that's what, 6x? Minus 27 is greater than or equal to 7. Now what?
Add 27.
Add 27, good. So that's going to give me 6x is greater than or equal to 34. Now what? Okay, divide by 6, good. Divide each side by 6, and that cancels the 6's. And so I get x is greater than or equal to 34/6. Can that be reduced?
Pretty sure.
Yeah, what can I divide both numbers by?
2.
Yeah, I could divide, 3 I couldn't do, but I could do 2. So if I divide each one by 2, I'm going to get a 17 over a 3. So x is greater than or equal to 17/3 is my answer, right? So if I want to graph it on a number line, I guess we got to think about, now we never want to write mixed numbers anymore. Mixed numbers are middle school stuff, right? That's not high school stuff. But if, I might want to know what would this be as a mixed number. So if I were to write that as a mixed number, I would get what? 3 goes into 17 how many times? 5. And how many are left over? 2. So 5 2/3. So if I wanted to come down here, let's just say that's 5 and that's 6. I'm going to put my endpoint right about there, ish, right? Solid or closed? Or open?
Close.
Good, closed. And I'm going to shade in which direction if I want the x values greater than or equal to my endpoint? To the right, good. Okay, how would I write that using inequality notation?
5 2/3.
Okay, but I'm going to leave it as fractions. So 17/3. 17/3, comma,
Infinity.
infinity. That's it. Questions on that? Yes, exactly. Closed, the ones that are closed are brackets, and open are rounded parentheses. Good. Okay, let's try one more like this. What do I do? Okay, what am I distributing? The negative, which is the same thing as distributing -1. Good. Same thing, but we can think of it as just distributing the negative, that's fine. So I get 3 minus 4m minus 1 is greater than or equal to 5m minus 25. 3 minus 1 is just 2. Okay, so now which side do we want to collect the variables on? Same as always. The right side. I would say it's even a little bit more important when you're working with inequalities, and here's why. It's going to work either way, and with the equations, it's not that big a deal. But if I've got an inequality, if I were to subtract the 5m to this side, I'm going to end up getting a negative number of m's, right? I'd end up with a negative 9m, and eventually, to get that m by itself, I'd have to divide both sides by -9 down the road. Agreed? What's dangerous about that? Dividing both sides by -9. I gotta remember to flip it, and that's easy to forget, right? So it's even more important when you're working with inequalities to always push the variables to the side where you get a positive number of them, right? So we could add 4m to both sides. And if I'm pushing the variables to the right, I might as well take care of two things at once. I'm gonna push the numbers where? To the left. So what do we get there? We get, on the left side, the variables are gone. 2 plus 25 is 27. On the right side, 5m plus 4m is 9m, and the numbers go away. So 27 is greater than or equal to 9m. Last step. Divide by 9. Okay? And I get m on the right side, 3 on the left side. Now that's fine, but how could I write that better? If I read that one from left to right, it looks like 3 is greater than or equal to m, right? I really don't want to start with the number. I want to start with the variable. I want to know how is the variable related to its boundary. So I'd rather say m is less than or equal to 3. If I write it like this, I would start with the m, but it's easier just to flip that whole thing around, isn't it? I could just turn that into m is less than or equal to 3. That'd be a little bit better answer. Does that last step make sense? Okay. So there's my answer using inequalities. What would my answer be using interval notation? Okay, I'm going to have close on the, does it have a right boundary or a left boundary? It's got a right one because we want all the values less than, meaning to the left of 3, right? So 3 is our right boundary, and that's correct that it's closed. What goes on the left? Negative infinity, good. And if this is 3, that's my graph, isn't it? Okay? Couple weird ones here. So what about something like this? It says solve the inequality 4 times, I'll tell you what I'm going to do. To make this, let me change this a little bit. I just built some better questions over lunch to replace these. Okay, so I had these set up before where I was going to give you separate problems to use both notations. But I thought, why? I need to do the work twice. So this way you can take care of 2 questions in one. So let's look at one like this. This is how all your problems are going to look on the solve the inequality, write your answers in the appropriate boxes below. Well, you can't see the boxes, but they'll be in the middle. Here's the inequality we're solving. I want you to write your answers using both inequality notation and interval notation. Okay? So first we're going to write the answer using inequality notation and then using interval notation. So let's do this one first. Let's do the problem and then we'll look at how to write our answers. Okay, what should I do there? Distribute, good. So if I distribute the 12 to both terms, I'm going to get, what's 12 times 3?
6.
So 36x, 12 times 8? 96, good. 18 times 2x? 18 times 3? What's 3 times 10? There you go, 30 plus 3 times 8 is 24, 30 and 24 is 54. Okay, now what though?
Ooh,
What happens?
gives margin.
The 36's go away. I can't push the variables anywhere, because when I subtract 36 from each side, the variables go away. And I end up with the equation 96 is greater than 54.
That's facts.
That's facts, right? So what happens if we get a true statement? If the variables disappear, we get a true statement. It happened before to us. Same answer. If the variables go away and I get an answer that is always true, what do you think the solution is to this inequality? No, if it's always true, all reals, right? So it's true. Oh. So let's look at our two kinds of answers then. For inequality notation, how would we say all reals? Just capital R, just a regular capital R. It's too hard to go find that real number thing, so we just put a capital R for all reals. What about for part 2 though? Part 2 is where we want to write it using interval notation. So in interval notation, how do you think using infinities and commas and parentheses and brackets, how could we say something that means all possible real numbers? Would there be any endpoints? If I'm including all real numbers, no endpoints, so how would I write that? Okay, I've got to put, well, I could go up to positive infinity, but I have to also be able to go all the way down to negative infinity. So everything in between, which is all possible numbers, that's how I would write all reals using interval notation. Okay? That makes sense? It does kind of make sense, doesn't it? Right? There's no endpoints, just everything. Okay, let's try one more like that. Say it again. Yeah, you have to put the parentheses. Yep. All right, one more of these. So what about this one? What we got to do there? Distribute the negative. If I distribute the negative, I'm going to get, okay, if I combine like terms, 5x plus 9x is 14x. Okay, just like before, if I subtract 14x from both sides, the variables go away. Okay, this time I end up with negative 4 is less than or equal to negative 6. True or false?
False.
False. So there's no solutions, right? So for part 1, if I'm using regular inequalities, there's no fancy way of saying that. We just put n for no solution. But for part 2, if I'm using inequality or interval notation, there is a special way we say empty set, where nothing is, there's no interval where there are any solutions. We use what's called the empty set symbol. Okay, and the empty set symbol just looks like that. And where you find it is in the drop-down menu for it's like the pie drop-down menu. You hit that little drop-down, it's on there, okay? So I'm gonna show you one thing here. When you're doing these problems, just so you're aware, here's a problem. So here's your answer boxes, but notice that the answer boxes don't have the little algebra editors. How do I open them up? Because you're gonna need them for both these answers.
Click on the square root.
Yeah, if I click on that little square root symbol, it opens up an answer. And so let's just say hypothetically that my answer is x is greater than or equal to. So I got to go up here, greater than or equal to 5. Now I hit enter, it pops it down there for me. Okay, does that make sense? Okay, and if I get one of these, what is the answer? This one was supposed to be no solutions, right? So down here I'm going to go find that symbol. It's on the pie, so it's right there, empty set. And if I check, it does give you half. If you get one of them right and one of them wrong, you get half credit. Now I can still reload them for full credit. Okay, make sense? All right. Oh, what I want you to do here, here's the next plan. So